Graphing motion. So motion is graphed using distance time graphs. So we have our time on the x-axis, and we have our distance up here on the y-axis. Okay. Now, scales must fit values to be graphed. This is kind of normal for graphing anything. The scales have to be appropriate to what you're graphing. Scales must also be in equal intervals. This does form an XY scatter plot if you're doing this on a computer. Okay, so you'd have your time broken down into equal intervals. So this is 0 minutes, 10 minutes, this would be 5 minutes, this is 2.5 minutes, etc. This is done in 200-meter increments going up the y-axis. In a computer program like Numbers or something, you would actually plot the data. You'd actually put your data in. You'd do it as a scatter plot, which is the one that looks something like this. It has a bunch of plus signs in it. You'd graph it as a scatter plot and then connect the dots. So you don't want to use like your line graph function in there. It messes it up. It does a weird thing. So you want to plot this as an XY scatter plot on a computer and then go in and set it to connect the dots. So you'd actually get a graph that looks something like this. Now, speed on distance time graphs. So constant speed means the increase in distance is the same over equal time intervals. In other words, it's a straight line. Okay, so if you have a straight line on a distance time graph, that means you are traveling at a constant speed. So steeper slopes indicate faster speed. So if we look at the graph over here, we have this red line, which is for Mary, and she is moving at 80 meters per minute, which is kind of a weird unit, but 80 meters per minute. Kathy, down here in the blue, is moving at 60 meters per minute. And notice this slope is not as steep as this one. So over this given time, like 30 minutes, well, Kathy has only gone 1,800 meters, whereas Mary has gone 2,400 meters. So she's moving faster. She's moved further in 30 minutes. Julie down here starts off at 40 meters per minute, so we have an even flatter slope here. Stops for 10 minutes, which is basically this flat horizontal slope here, which is 0, so velocity equals 0 meters per minute here. And then she basically starts moving again at 80 meters per minute here. Okay, so this is a changing speed. These are all constant speeds. This is constant for 10 minutes, then changes for 10 minutes, and then is constant for another 10 minutes. Now, a flat horizontal line indicates sitting still. It means 0 meters per second. You're not moving. And if you kind of look at that, that makes sense because you go 10 minutes here without changing your distance,